Hey everyone, Tim here from SnapAttack. Let's dig into this week's Threat Snapshot. So today we're going to feature a great community resource, and this is the Atomic Spotlight project. This is put out by Carrie Roberts. She's one of the maintainers of the Atomic Red Team project, and as well as a trainer with Antisyphon training. And she puts out these great videos highlighting various atomic techniques in the framework, how they work, doing a deep dive into them, and discusses some detection opportunities, and ultimately is a really good resource for learning about the attack. So we're going to take a look at the most recent video that she released, actually a day or two ago now. So this is a persistence technique with the Netsh helper DLL. So I'm going to keep our video here on the little bit shorter side, but you can definitely check this out. You can see, again, she does a really good job explaining the technique, goes through running this in the Atomic Red framework, and talks through some of the things that you can look at. So we'll take a look at two of these here in SnapAttack just to kind of give our own flavor to this. So first one is going to be the atomic test that's part of the Atomic Red Team framework. You can see here it's for T1546.007 event triggered execution. This is the NetSH helper DLL. And for a little bit of background, NetSH is the network shell, or net shell for short. Chances are, if you've been doing anything network related on the command line, like typing in netsh advanced firewall to, again, either create a firewall rule, turn it off, or some other networking commands, you've probably used this. So it is a built-in Windows utility, and it has kind of a very interesting feature. This is the helper DLL function where if you are extending or using certain features there that require additional code, you can have a DLL loaded every time NetSH is run. So you can see here where this could be useful for legitimate purposes, but also as an attacker, this is a great persistence mechanism. I can register a malicious DLL here, include a Cobalt Strike beacon callback, or any sort of code that I want to execute. And anytime a user runs NetSH on the command line, it's going to trigger that DLL load. So very ripe here, opportunity for abuse. You can take a look here at what the atomic test is, and it's a very simple NetSH command, and it's the add helper with the path to the DLL. So in SnapAttack, we do have all of the Atomic Red Team techniques, so you can take a look at this. You can see, again, the description. Do want to call out, we do have a new feature with the latest release, and that's our recommended detections. So we can see here that this, for this captured threat, it's recommending us to deploy this NetSH DLL persistence detection. We'll actually take a little closer look at that. But again, in true SnapAttack fashion, you can see, again, a video of the attack. Again, you can see the commands being typed on here. You can see the detections as they hit. And really, this recommended detections here is to help prioritize that. The other technique that Carrie highlighted in her video, which again we also added to the platform, this is another open repository. You can see this is definitely an old technique, updated 6 years ago, but still very much valid. This is a framework which allows you to, again, if you wanted to have your beacon shellcode to load beacon as a DLL, you could certainly use this to launch that. We went with a little bit simpler version of the shellcode for ours here. So this threat here is available to subscribers. You'll also see it does have a similar recommended detection. But if we want to take a look at the video here, see the attack. So again, we've compiled our own version of the DLL. It's got shellcode to just simply pop calc. So we're going to do a NetSH add helper with that DLL file, and we'll see a calc pop up here shortly thereafter. Fun thing is that actually loads when you run the add command, and then it will load on subsequent commands. So we're just going to run NetSH here again, and you're going to see that calc pop up. Obviously, if you're an attacker, you're going to do something a little bit stealthier than pop a calc. You're going to not be popping up windows at all, and that would be a great way to kind of silently trigger a beacon or whatever your C2 framework is. Again, lots of different detection opportunities here. Taking a little look at this on the process graph just to kind of see the view here. So again, we have that NetSH add helper command, and then we can see here that something is going to be spawned from NetSH. So in our case, we have a CMD spawning calc.exe. That could also be, loading something else. So definitely want to take a look and see. There are some good detections around what are suspicious child processes of netsh.exe, which you could certainly do. The ones here that we are recommending and that, more specifically our algorithm is helping to suggest. So we've got two detections here. This first one, netsh DLL persistence, is really looking at the registry event. So when you run that add command, it is creating a registry key, HKLM software, Microsoft NetSH, and it's putting in the helper DLLs in a hive here. So you see that file and then the path. So this detection here, again, it's going to be high confidence. This sort of activity doesn't happen a lot in production environments. So it should be pretty rare, and this should be something that you can detect on and alert on pretty easily. So yeah, I could take a look, I could review this, I could test this in my environment, and then with one click in SnapAttack, I could deploy it to a tool, such as Sentinel-1, and then have coverage for this, technique. Another thing to highlight here is we'll hit this other detection. So this one is from the Sigma community repository. This is a suspicious netsh DLL persistence. Again, we've been able to validate that here in the platform. This one here is specifically looking at the command line. So you can see image is netsh, and it's looking for the add and helper commands to be present there. Certainly, high quality, high confidence detection, as long as they're using the command line to actually add this persistence. If there were some other ways that this technique was added, you would be much more effective looking at the registry key, which is, again, why we're prioritizing that detection. So anyways, that's a little bit about netsh persistence mechanisms. Hope you enjoyed this snapshot. Definitely check out the Atomic Spotlight series as well, and we'll see you next week.